Welcome back. We're in week 13 and talking about continental drift and the evidence that has supported the idea. You'll need to be able to show how magnetic polarity supports continental drift by the end of this lesson. After Wegener's death, the continental drift idea was pretty much dead. It would have remained that way except for the development of certain technologies. Using technology, scientists would find more evidence that continents had indeed drifted. They would also be able to find the mechanism, the way that it was able to move continents on the surface of the Earth. Some important evidence for continental drift came after Wegener's death. The following is the magnetic evidence. Earth's magnetic field surrounds the planet from pole to pole. If you have ever been hiking or camping, you may have used a compass to find your way. A compass points to the magnetic North Pole. The compass needle aligns with Earth's magnetic field. Some rocks contain little compasses too. As lava cools, tiny iron-rich crystals line up with the Earth's magnetic field. These crystals are magnetite crystals. Anywhere lava has cooled, these magnetite crystals point to the magnetic poles. The little magnets point to where the North Pole was when the lava cooled. A magnetometer, as seen here, is a device capable of measuring the magnetic field. A magnetometer can be used on land. A magnetic meter can also be dragged behind a ship, as you see in the picture. Geologists used magnetometers to look at rocks on land. They wanted to know which direction the magnetite crystals pointed. This would tell them where the magnetic north was at the time the rocks cooled. And this is what they learned. Magnetite crystals in fresh volcanic rocks point to the current magnetic North Pole. Older rocks that are the same age and are on the same continent point to the same location. However, the location they point to is not the current North Pole. Older rocks that are different ages and are on the same continent do not point to the same location. None of them point to the current magnetic North Pole. Rocks on different continents that are the same age point to different locations. Only recent rocks point to the current magnetic pole. How do geologists explain that? Well, there's only one logical explanation. There is almost certainly only one magnetic North Pole through Earth's history. The North magnetic pole is very likely the same spot it has always been. If these two things are true, then it is the continents that have moved. Geologists tested this idea that the pole remained fixed, but that the continents moved. They fixed the continents together as Wegener had done. They moved them into the positions where they had been at the time the magnetite crystals cooled. The magnetite crystals pointed to the current magnetic North Pole. The magnetic pole seemed to have moved, but it had not. They named this phenomena apparent polar wander. In this picture on the left, the apparent North Pole for Europe and North America, if the continents were always in their current locations. The two paths merge into one if the continents are allowed to drift. Geologists are now more interested in continental drift. More than ever, they needed a mechanism. So in summary, magnetite is a magnetic material found in lava. The magnetite points to the magnetic North Pole when the lava had cooled. Scientists use magnetometers to show where the North magnetic pole had been when magnetite crystals cooled. Magnetite crystals of different ages and on different continents point to different spots. The simplest explanation is that the continents had moved. Apparent polar wander is another line of evidence for drifting continents. So, now that we've discussed magnetic polarity, can you see how it supports the theory of continental drift? If you can explain this, good for you. You can move on to the next activity. If not, please go back to the video one more time and view it once again. Thanks for being here. Talk to you soon.